Alright, hey everyone, Maya here, and this is another episode of Mathelingual. Now, as you've probably already noticed, kind of done a little rearranging here, so hopefully this will make it a little easier to see the board, I guess. Okay, so last week I finished up going over inequalities in general, I think specifically and/or inequalities, right? And now we're going to get into absolute value inequalities. Equations, inequalities in general, but today I'm going to be touching base on an equation example. So first off, I just want to point out absolute value. So when we have like this, like these two straight lines, that tells you it's absolute value of a number, let's say a number x. So absolute value is going to tell us the size of the number, right? The absolute value, not direction. So like let's say the absolute value of x is 5, right? So that means x can be positive 5 or x can be negative 5, because you think about it, I'm going to draw it out real quick. When you think about it on a number line, let's just say, nothing too fancy here. Okay, so 5 and negative 5, yes, they are different numbers in terms of direction, right? So like negative 5, you're going from 0 to the left, and from 0 to positive 5, you're going to the right, right? So they're different directions, but they are the same distance from 0, okay? So the absolute value of negative 5 and positive 5 is going to be just 5 for both of them, okay? So absolute value tells us the size of the number, right? Its distance from 0. And that is different from telling you the direction, which is what the sign indicates, a direction, right? Okay, so touching base on this, so basically for the absolute value of a number x, it's going to be x if x is greater than or equal to 0, right? Because if x is greater than 0, it's going to be positive, right? So you're just going to have like x, okay, like positive x. But it's going to be negative x if x is less than 0, right? Because if x is less than 0, you're going to have a negative number, which means, you know, it's going to be a negative x, okay? So now let's jump into the quick example, now that we've got those basics covered. So absolute value, just think of that. It literally is what it sounds like, absolute value, not absolute direction, absolute value. Okay, so here's our example. The absolute value of 2x minus 1 equals 5. So now when you're solving an absolute value equation, the definition of absolute value, which I just went over, means that for an equation like this, there are going to be two solutions, okay? So basically, we can split this up into two equations. Yeah, I've been using this marker for a long time now. Okay, so two equations. So we can either have the absolute value, not absolute value, because we're already breaking that down. It's already written. Okay, so the absolute value of 2x minus 1 equals 5. That means we can have 2x minus 1 equals 5, positive 5, or 2x minus 1 equals negative 5. You see? Because remember, this expression, this algebraic expression, goes up in here between the absolute value lines. So that means if you get a positive 5, you put it in here, its absolute value is going to be 5. You get a negative 5 from this expression, put it in here, your absolute value is still going to be 5, right? Because we're just talking about the bit in here, okay? We're talking about in here, which is still going to have these absolute value lines that give you 5 as your value, your size of the number, okay? If that makes sense. We're not taking the whole absolute value and saying the absolute value is negative 5. No, that's impossible, because actually absolute value is non-negative. You can't have it negative. The only way you could have it negative is if you have like absolute value and you have like a negative outside. But we're not doing that, right? We're just focusing on the simple absolute value. So let's solve these two equations. It's very simple, just a little bit of algebraic manipulation, inverse operation. So 2x minus 1 equals 5. You're going to add 1 to both sides to start isolating x. So that is 2x equals 6. Divide by 2. 2's cancel out on here. So x equals 3. Okay, now over here, same principle. We're going to add 1 to both sides. Okay, 2x equals -4. Divide by 2, and that means x equals -2. All right? So now you have two solutions. So we could even go on a number line to graph these. I know okay. That or line apparently was a big nuisance in my number graph. Okay. So let's say we have, let's see, 1, 2, 3, 4, 5, 6, 7. Okay, so 0, 1, 2, 3 to the right. And then to the left, -1, -2, -3. And notice, this is the case for all opposites. You know, we talk about opposites in math, like -3 and 3. They're both 3 units away from 0. It just depends on what direction you're talking about. But absolute value, -3 and 3 would both be 3 because they're both 3 spaces away from 0. -2 and 2, both each 2 spaces away from 0. You can go on and on and on. Toward positive infinity, toward bigger positive numbers, or toward negative infinity, toward bigger negative numbers. You take a number and its opposite, they are both going to have the same absolute value because, again, the only thing that is different about them is their direction. That's it. Okay, so for this problem specifically though, x equals 3, so our solution is over here, 3 and -2. Okay. So now what we can do is check, and this is where that idea I was talking about earlier, that we're only taking the part inside the absolute value signs within those absolute value symbols. This is where it's going to come in handy. When you check, you're just going to plug in that solution. So let's see. We had the absolute value of 2x minus 1 equals 5, right? So let's start with the x equals 3 solution. Does 2 times 3 minus 1, does the absolute value of that equal 5? Well, we've got 6 minus 1. Remember, still in absolute value. Okay? The absolute value of 5, is that 5? Remember, this is positive 5. 5 equals 5. So that's good. Right? What about for the other solution? All right, come on, work with me, marker. Just need you for the last minute of this. Okay, now, same principle, just with the x equals -2. So just 2 times -2 minus 1. Remember, absolute value. Does the absolute value of that equal 5? Well, we're going to find out as we check. So, -2 times 2 is, of course, -4 minus 1. Still putting a question mark because we haven't totally simplified it yet, even if you already worked this out in your head and figured out it's correct. Well, I'm just going through it for the sake of clarity and approach. You know, show your work. Okay, so -4 minus 1, -5, and the absolute value of -5 is, of course, 5 because it is still 5 spaces away from 0. And so, that's how and there you have it. Okay? X equals 3, x equals -2, both satisfy the absolute value equation. So that wraps it up for today. So hopefully you took a little bit away from that about absolute value, and to be continued in the next videos, in the next weeks, whatever. Okay. Mathlingual, Maya out.